Welcome back to BAS 121. We're on Chapter 9 talking about regression models and analysis. Now, we talked about regression and we talked about it for numerical data and how it has to be numerical. In our last example, we showed you how if you have one categorical set of data, you can convert that to numeric using a dummy variable. And as you remember, we went into our example here and we had to say whether they were an MBA, yes or no. We had to convert that one categorical field to a numeric field by basically doing a 1 if it's yes and a 0 if it's no. But what if we had several categorical data, which we have right here, where we're trying to predict surface finish, and we've got RPMs, and we've got different cutting tools. So we want to understand which cutting tools, how they impact our surface finish. So the first thing we need, here's the raw data. What we're trying to predict is our surface finish. So that'll be our Y variable, or our dependent variable. We know we need to convert all of these to numerical data using W variables. So our independent variables, which will be used to predict our dependent variables, we'll use the RPMs, which already is in numeric. We've got to somehow convert type A, type B, type C, and type D from categorical data to numeric data. Now, a trick you use is you might intuitively think we're going to convert all of these, but that causes some statistical instability in our data. So what we're going to do, a little trick, is we're going to convert these three, type B, C, and D, and then by default, if all of those are false, then it's going to be type A. I'll show you right now how we converted the data. Now, I put the cutting tools over here to the side so it doesn't mess up my, when I start doing my regression within Excel, the different fields. And what I did here is we said for type B, we said if this column is B, put a 1 in there, otherwise a 0. And a little bit of a trick, we put a $sign in front of the column so it'd be easier to copy both down and to the right and to the left. This is the same equation except if it's type C. Same equation except if it's type D. Just copied these all down, made a quick check. Notice that if it's type A, we have 3 zeros. Notice if it's type B, there's all our type B's, there's all our type C's. So our data looks pretty clean. And then we just went and we did data analysis, regression. We did our ranges. There's our Y range, our surface area. There's we did our X range, which was this stuff. And we ask it to output it right down here. Now, very good model. Right off the bat, we see our adjusted R. Remember, we do use adjusted R when we have multiple independent variables. But 99% of the deviation in surface area is explained by the variables. The tool type and the RPMs explain 99% of the variation in surface finish. Quite amazing. Notice our F, of course, is extremely high, and our significant F is, that's the probability that we would get this by chance is almost insignificant, 10 to the negative 29th. We look down here, all our p-values and all our coefficients, we want them to be less than 0.05. Well, they're significantly less than 0.05. And here's our coefficient so we can set up our equation. So our equation is going to be surface finish equals 24.49. Now notice if it's type A, we're just not going to add anything to that 24.49. So times the factor for the RPMs. So we notice this is, since it's positively correlated. So as RPMs go up, our surface finish will go up. And then we can see, since these type B's and C and D are all going to be slightly worse than type A because they're a negative sign in front of them. And there you have it. So if it's type A, what's going to happen is these last three variables just will all be zeros, and you'll still calculate it for type A, for type B, for type C, and for type D. So there you have a great model. We've converted all the four categorical data into our equation, and we have a great regression model. Any questions? Let me know.